Alright, so I'm on page 156, and the title today is called Binomial Theorem. Binomial Theorem. Alright, the binomial theorem is a quick way to expand a binomial expression that has been raised to some, in parentheses, generally inconveniently large power. For instance, comma, the expression (3x minus 2) quantity raised to the 10th power would be very painful to multiply by hand. It's 3x minus 2 raised to the 10th power. We have to do 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2, and all that distributing and combining like terms. Can you imagine? We would need the whole board to do that. So the binomial theorem is a way that will help you multiply that all out in a much more convenient and fast or quicker way. So the way I'm going to show you how it works at first, we're going to start with just a simple binomial so you can like start to recognize the pattern, okay? So let's use the simple binomial a plus b. I'm going to put a little star, but it could be any binomial, okay, as long as it's a binomial. Two terms, a term plus another term, a term minus another term. Okay, when you have a power of 0, what is 5 to the 0 power? 1. What is 10 to the 0 power? 1. What's negative 1,000 to the 0 power? What's x to the 0 power? What's a plus b quantity raised to the 0 power? 1. So if we have an exponent of 0, we know that a plus b quantity raised to the 0 power gives us 1. Am I right? Yes, Miss Rayleigh. What about if we have an exponent of 1? That would be a plus b quantity raised to the first power would be what? A plus b. we have an exponent of 2? So that would be a plus b quantity squared, which is not a squared plus b squared. Remember, that means a plus b times a plus b. And if you FOIL all that out and get like terms, you would end up with a squared plus 2ab plus b squared. Once you distribute and combine like terms, right? Otherwise, it's a squared plus ab plus b squared. Then you combine ab plus ab and you get 2ab. Nothing new so far, right? Have not learned anything today. If you have an exponent of 3, that means a plus b quantity raised to the 3rd power, which is the same thing as a plus b times a plus b times a plus b, which I'd probably FOIL my first two together, combine like terms, and then distribute it to the last binomial. And once you do all that, you would get a cubed plus 3a squared b plus 3ab squared plus b cubed. What? Everybody cool so far? Cooler than the other side of the pillow. So let's just look at a plus b quantity cube, okay? So a plus b quantity cubed, that's the factored form of this right here, which is in standard form. Does anybody notice a pattern in that standard form of that cubed binomial? Do you see any sort of pattern? Anyone? What do you mean?
A plus
Okay. Anybody else see anything? They all have an A or a B, sometimes both, right?
starts at an A and then ends at a B.
Starts at an A and ends at a B. That's true. How many? What's the exponent of A in the first term? 3. What's the exponent of A in the second term? 2. 1. 0, right? If there's no A, it would have been A to the 0, which is a 1, right? 3, 2, 1, 0. What is the exponent of B in the first term? 0. If it's not there, it has exponent of 0, right? So 0, exponent of B, 1, exponent of B, exponent of B, 3. So the A's started at 3, went 3, 2, 1, 0. The B's started at 0, went 0, 1, 2, 3. You see that? Oh. Now at this point, we don't know anything about the coefficients, like how we got those. But that pattern is going to be true whenever you have a binomial. If you raise it to the second power, third power, fourth power, 20th power, the first term's exponent will be the same as what you start with, and it'll go all the way down to 0. And then your second term basically will start with the exponent of 0, and then we'll go all the way up until it gets to whatever the exponent was outside the binomial. Right, same thing here, and then here it's 0, so I mean it's hard to see, but if we did this to the fourth power here, this A would start at 4, and the B would be non-existent, and it would go A to the fourth, A cubed, A squared, A to the first, no A. And B would start at B to the 0, which is nothing, then B squared, B cubed, B fourth, you know what I mean? Okay, so I'm going to put here, let's see, exponent of A, we got 3, 2, 1, 0. And the exponent of B, 0, 1, 2, 3. So like whatever that binomial is being raised to, that's your magic number when you're doing the binomial theorem. Now all this time that we foiled out binomials, when we do first, outer, inner, last, we could totally use binomial theorem, but it takes way too much time when we could just foil it. The binomial theorem is good for if this is to the 5th power, the 10th power. Like some big exponent, this is a lot of work, but it'll be a lot more work if you actually multiplied it out long ways, like foiled all your binomials and then distributed them and combined like terms. The binomial theorem is shorter. Not always shorter. If I was just a plus b squared or a plus b cubed, I'd totally just do that a long way. Even a plus b to the 4th probably. All right, I'm on page 157. Alright, so I want to make a note that this pattern helps us with the exponents. This pattern helps us with the exponents. Of the variables, but not with the coefficients. What we're going to use to help us to figure out what the coefficients are of each term is called the Pascal's triangle. Has anybody ever heard of that before? Pascal's triangle. And you're going in, it wants plenty of room to to help refer back to this. Now, you wouldn't be given the Pascal's triangle on a test. You would have to be able to come up with it on your own. And it's not something like you have to memorize all of the numbers in the Pascal's triangle, but you do have to know the pattern, and then you could build it yourself, okay? So the Pascal's triangle always has a 1 at the top of the triangle. All right? And then the next layer, because you have 2 boxes, and they both have a 1 in it, because you always have a 1 on the outsides of the pyramid. Always, 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 always. So in my next triangle, so this is how I make the boxes, so I make sure everything's lined up correctly. Under each box, at the middle point, I will draw a line down and go to the left of it, and then to the right of it. So now you've got 3 boxes. Again, you always have a 1 on the outside. And in that middle box here, I'm going to put a 2. Not going to tell you where I got that from until the next row and see if y'all can figure it out. So in the next row, I'll have 4 boxes across. So like I said, I go to the middle of each box basically, and that helps me just to make sure everything's lined up correctly. On the ends, I have a 1. Now I've got a 3 and a 3. So 1, 3, 3, 1. Be thinking of how I'm getting those numbers. I'm going to ask on the next one. So in my next row, got a 1 on the end. And I've got a 4, a 6, and a 4.
Oh, I got it. I get it.
Can you explain it to us? How you're getting those numbers?
The numbers on top of the added together. So like the 4, the 3, and the 1 is the 4, and then the 3.
Very good. You said something about Minesweeper. I don't know.
Minesweeper?
I don't play that game, but it's probably based on math. So like, you always start with the 1 on the edges. You start the 1 on the top, and you have to have a 1 on the edges, okay? But after you get these to the 3rd layer, you have a 1 on the edges. To get 2, the 2 boxes that made it above, add those together to give me 2. So for 3, 1 and 2 makes 3. 2 and 1 makes 3. That's how I got that 3. For 4, 1 and 3 makes 4. 3 and 3 makes 6. For 4, 3 and 1 makes 4. You always have a 1 on the end. Okay? That's why you want to make sure everything's lined up, so you make sure you're adding the right boxes together. So in my next row, put a 1 on the end. So I would have 5, 10, 10, 5. I'm going to go all the way down. I'm going to do, we are at we call this the 0 row. 0, 1, 2, 3, 4, 5. I'm going to do 2 more. One's always going to end. So yeah, 6, 15, 20, 15, 6. One more row. And you can keep going on and on and on and on and on and on forever. But we're just going to do one more. So I'll have 7, 21, 35, 35, 21, 7, and then the 1 on the end. I know. So I'm saying, you only really want to use this if you have something crazy like x plus 5 raised to the 10th power, okay? But if you had the triangle handy, like you didn't have to draw it out and you had it handy, then easy, because you'll see in a minute what these numbers are going to tell us, all right? Real quick, let me point out, on the one that we did the a plus b to the cubed, right, on the previous page, when we did a plus b raised to the 3rd power, we got a cubed plus 3a squared b plus 3ab squared plus b cubed. Notice our coefficient here was 1. The second term the coefficient's 3. The third term the coefficient's 3. The first term the coefficient's 1, right? So 1, 3, 3, 1. Look where that came from. 1, 3, 3, 1. That came from Pascal's triangle, okay? Because it was 3rd degrees, we're going to go down to layer 3, and that's how we're going to find our information. So again, we call the first layer layer 0. Starts at 0, so 0, 1, 2, 3. So 3 degrees, we get our coefficients from there. 4 degrees, 5 degrees, 6 degrees, 7 degrees. So if I had like a plus b raised to the 7th power, this would be my coefficient of every term. And then we know I'd start with a to the 7th, a to the 6th, a to the 5th, a to the 4th, you know, all the way down. And b would start at b to the 0, b to the 1st, b to the 2nd, all the way up to b to the 7th. And we get our coefficients from Pascal's triangle. How cool is that? What?
You know, like everything after you factor like that.
Yes. If you know how your exponents of the variables, the first one increases and the second one decreases, and you know this, you have everything you need to write out your expanded form without multiplying anything. Okay? So let's do one. And we're not going to get crazy. I mean, we're going to go up to, like the highest exponent that we may do is 7. So we're going to start out small. So armed with this information, let us try to expand a plus b quantity raised to the 4th power. When it says expand, just means multiply all that out. A plus b times a plus b times a plus b times a plus b. FOIL it all out, get in standard form. Okay? So we can do that. We know how to do it long-handed. We're going to do it using the binomial theorem. Right on? And the way I'm going to write this out and put it together, when you do it on your own, you may go straight to putting it all together, but y'all know how I am. I'm going to show you every little thing I do first, and I want you to do that in your notes, and then on your homework, you can just go to put it all together if you can see it that way. So my first term, my A, I'm just going to do it each part separate, okay? So what would A's exponent be in the first term? 4. And then it would be A 3 or cube, a square, a to the 1st, and a to the 0, which is just a 1, but I'm going to put that there because realizing I have to have 1, 2, 3, 4, 5 terms, 4 degrees, I need 5 terms because it goes all the way down to here, right? So my second term is b. What would b start with? B to the 0th, and b to the 1st, b squared, b cubed, and b to the 4th. All right, so those are my A's and my B's. Now I got to look at my coefficient. What row am I going to go down to? Row 4, right? So my coefficients, my first term will have a coefficient of 1. My second term will have a coefficient of 4. My third term will have a coefficient of 6. My fourth term will have a coefficient of 4. And then my last term will have a coefficient of 1. So I'm going to use everything, and then I'm going to go back and simplify it. Again, I know in your homework, you're probably not going to do this many steps, but I am. And everything was positive, so I know in the end everything's going to positive. When I multiply positives together, I can't get a negative. So this would be 1 a to the fourth b to the 0 plus 4a cubed b to the first plus 6a squared b squared plus 4a to the first b cubed plus 1a to the 0 b to the fourth. And of course that's not all cleaned up. So I'll do that now. So what is 1a to the fourth b to the 0 simplified? Just a to the fourth, right? And then plus, only thing to simplify here, I don't need to b to the first, so just plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus, that will just give me b to the fourth. Pretty cool, right? Totes my goats. I said that one in a while.
Yeah, just leave that.
Just leave it like that.
Yeah.
Trying to say.
Leave it where you.
Stay ahead. You have a question on that? Now you're not just going to have an a plus a b. You're going to have other terms. Like I could do 2x minus 3. The 2x would be where whatever my a is. The minus 3 would be what my b is. Now we go through the same pattern. We're not going to get all into that. I just want to introduce it to you so that you're familiar with it. Okay? So on my next page, I'm going to do a plus b quantity raised to the 5th power. Yeah. If I would have multiplied all this out, a plus b times a plus b times a plus b times a plus b, boiled it and distributed it and combined like terms and all of that the long way that we know how to do already, if I would have done all that, this would have been the standard form of what I would have gotten. Okay? It's just a shorter way to do it. Well, shorter if you have Pascal's triangle handy. Alright? Even if not, it doesn't take that much to write it out. So we're going to expand a plus b quantity raised to the 5th power so in my first term, I like to write my a's out first, my first term, then my second term. My first term would be a to the 5th, and then a to the 4th, a cubed, a square, a to the first, a to the 0. So 1, 2, 3, 4, 5, 6. I should have 6 terms. Got to make sure you do a to the 0. For my second term, we call it the b, when it technically is a b, would be, my first term would be b to the 0, and then all the way up to whatever the degree is of the binomial, which is 5. And then to figure out the coefficient of each term, we have to look at the 5th row of Pascal's triangle. So my 5th row, again, if you don't start at 0, your row is always going to be 1 off. So make sure you know that first row is row 0. And then we need the 5th row, 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And that is your coefficient. So we have my first term, second term, third term, fourth term, fifth term, sixth term. We just got to put it all together. This time I won't write everything out. I'll clean it up as I go. So my first term is going to be what cleaned up? A to the 5th plus
5 a to the 4th b
plus
10 a to the 4th
plus
10
a squared b cubed plus
5a
plus b to the 5th. Very good. Now we could prove that and actually multiply it all out and combine like terms if y'all would like to. You just gonna trust me? I mean, I didn't come up with it on my own. I didn't make it up myself. You can trust it. Yes. I do. Yeah. Some people can look at this and go right to this, because they'll just, each term they'll go ahead and look at what their coefficients are going to be, and then they know their A's start at 5 and the B will be non-existent, and then they can just write it in order like that. I like to kind of separate it all out and then put it together. I just think fewer mistakes are made if I'm more organized instead of just trying to go straight to the answer. You know what I mean? However, whatever you think is easiest to put it together. All right, let's do one more. Let's get crazy up in here. We're going to do a plus b raised to the 7th power. You want to try to just go straight to the answer? Let's just try it. Okay, first let's look at what our coefficients are going to be. We need row what?
7.
Row 7. So make yourself plenty of room. We're going to write these in order. These are going to be the coefficients. 1, 2, 3, 4, 5, 6, 7, 8. 8 terms, right? So I'm going to have a 1. And I may still have to clean it up, especially if a 1. 7, 21, 35, 35, 21, 7, and 1. I'm running out of room. And the first term, how many degrees is A going to have?
1.
A.
0.
A.
7.
A, 7, right? Your first term has the highest degrees. So A to the 7th, and then A to the 6th, A to the 5th, A to the 4th, A cubed, A squared, A, and then the last one's not going to have an A, right? I guess it's really not that hard to go straight to it. And then in my first term, B would be B to the 0, and then B to the first, squared, B cubed, B to the 4th, B to the 5th, B to the 6th, B to the 7th. And I pretty much cleaned it up as I went, but not perfectly, so I'll just rewrite it. In lieu of homework today, at least the class I'm recording this in, this may not be true for anyone listening to this, I'm going to give you one to do on your own, right here on your notes, on your own, and you are going to expand A plus B to the 6th. A plus B to the 6th. I paused it. I don't want the people watching the recording to see me writing. We're still working. We have 5 minutes unless you're leaving right now for Summerlin.
I already told you about that line.
Hey guys, I'm still recording this. I need you to be quiet and do what I asked you to do. I want you to expand this. Anybody finish? I'm just trying to beat the bell quick. So I got a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6ab to the 5th plus b to the 6th. Coolio? Anybody have any questions? All right.
Is that all?
Yeah.